Hi, students. Um, so, in the last chapter, we saw how covalent bonds between atoms are described, and we looked at the valence bond model, which uses the hybrid orbitals to account for the observed shapes of uh, organic molecules. Now, we have treated chemical bonds as either ionic or covalent. So, an atom may lose or may gain enough electrons para ma-acquire niya yung octet rule, yung 8 electrons doon sa kanyang valence shell and will become an ion. So, an ionic bond is the result of the force of attraction between a cation and an anion. Now, an atom also may share electrons with one or more other atoms to acquire filled valence shell, or yung para magkaroon siya ng para magkaroon siya ng complete 8 electrons dun sa valence shell. Magbabond siya with other atoms or elements. So a covalent bond is the result of the force of attraction between two atoms that share one or more pairs of electrons. Now, we have the term electronegativity. So, electronegativity is the power of an atom in a molecule to attract electrons to itself. And electronegativities are based on arbitrary scale. Okay, remember that. So, as you can see here, wait. So, as you can see here, yung ating noble gases, wala siyang electronegativity because filled yung kanyang valence shell. So, it has exact 8 electrons doon sa kanyang outer shell. Now, electronegativity generally increases from left to right. Okay? Dito sa atin, dito mula lithium hanggang fluorine. So, you can see from left to right, the electronegativity increases. And from top to bottom, the electronegativity decreases. So, with fluorine, which has, okay, so fluorine has the highest or the most electronegative with a value of 4.0, and cesium is the least electronegative. Okay, so those that are in red, so they are the most electronegative. So those that are in yellow, they are medium, and those in green are are the least electronegative. Okay, but most bonds are neither ionic or fully covalent. So they are somewhere in between, meaning yung bonding ng electrons are attracted more strongly by one atom than the other. So, mas nag-a-attract yung isang atom kesa dito. Mas nag-a-attract siya ng electron. So, so that the electron distribution between atoms, it is not symmetrical. So, it's unsymmetrical. Wala siyang equal distribution of electron density. Okay, so this figure shows the range in bonding from covalent to ionic. So this range is a result of an unequal distribution of bonding electrons between atoms. So first, we have the ionic bond. So ionic bond results from electrostatic attractions among ions. So ionic bonds are formed by the transfer of one or more electrons from one atom to another. Okay, so meron tayong distribution of electrons. Now, the compound formed by the combination of an anion and a cation is called an ionic compound. Okay? So, may guide para malaman din natin kung siya ay ionic bond based on sa electronegativity if the difference of the electronegativities of two elements like Na and Cl is 1.9 or greater. Okay? So, ang sodium natin has a valence electron of 1. Ito naman sa ating Cl ay 7. So, ang sodium natin, siya yung nag-transfer ng electron dito sa ating Cl. And as you can see, nagkaroon tayo ng charge doon sa ating Na. So meaning siya ay naging cation, okay? Kasi siya ang nagbigay ng isang electron. Now, yung ating chlorine, nagkaroon siya ng negative sign, which means siya ay naging anion. Ayan, kasi siya yung nag-receive ng ating electron. And also, ionic bond siya kasi meron siyang difference na between or 1.9 or greater. So, meron tayo, let's see. Okay. So, ang ating sodium has 0.9 electronegativity while ang Cl natin is 3.0. So, 3.0 minus 0.9 is 1.1. As 2.1, I mean. 2.1. So, their difference is greater than 2 or 1.9. So, which means ionic bond din talaga siya. Okay. So, next we have the covalent bond. So, covalent bond is formed by sharing one or more pairs of electrons. So, the pair of electrons is shared by both atoms and at the same time fills the valence shell of each atom. So, let's have these examples, the formation of hydrogen and fluoride, okay? So, when we combine two atoms of hydrogen, okay, so there is a shared pair of electrons, okay, ang nangyayari. So, at the ends of the line ay merong electrons dyan. Okay, so, next we have the fluoride. So, ito yung Lewis structure ng fluoride. It has a valence electrons of 7. Okay? So, yung nasi-share sila ng kanilang electrons. Kaya magiging ganyan siya. So, nagkakaroon tayo ng single covalent bond and meron tayo ditong tinatawag na sigma bond. Just what I have said on the last chapter that we discussed. Okay? Now, there are two types of covalent bond. So, first, we have the non-polar covalent bond. So, in non-polar covalent bond, there is an equal sharing of electrons between two atoms. Okay? So, when there's equal sharing of electrons, the distribution of electron density is symmetrical. And para ang non-polar covalent bond, nag-exist lang siya if yung two atoms ay the same element or they have the same electronegativity. Okay? And also, sa non-polar covalent bond, dapat ang difference nila in electronegativity would be 0.5 below. Parang ganon. Another type of covalent bond is the polar covalent bond. So polar covalent bond, there is an equal sharing of electrons between atoms in a molecule. So there is an asymmetrical distribution of electron density. So um, sa sa polar covalent bond, ang the more electronegative atom attracts the shared electrons more strongly and acquires a partial negative charge like this one. Kung ito man ay Na, kunyari this one is Na not H, okay? So yung Cl, nag-acquire siya ng negative. So negative charge. So meaning Cl is more electronegative than the sodium. So mas na-attract niya yung electrons. And the less electronegative atom attracts the shared electron less strongly. So nag-acquire siya ng positive charge. Okay? So, pag ganito naman, pag mag-a-assign tayo ng positive at negative charge sa ating mga covalent bonds, naglalagay tayo ng sigma bond, just like a sigma bond ng parang, what do you call that? Delta. Ng delta, okay? So, the delta also represents the dipole direction or the direction of the polarity of the molecule. So here is a guide for identifying the type of the bonds. So if the electronegativity is less than 0.5, we would consider the bond as nonpolar covalent. If its electronegativity differ by 0.6 to 2, okay, that's 0.6 to 2, that is polar covalent bond. But if the electronegativity differ by more than 2, so we would consider that bond as ionic. So first, let's have this methanol, I mean. So the bond between the carbon and oxygen is polar, okay? Because its difference in its negativity difference is 1.0. So ang carbon natin has an electronegative of 2.5, ang oxygen natin is 3.5. So nung minus na natin silang dalawa ay 1.0 yung difference nila. So, that means polar covalent bond. Also, yung paglagay natin ng ating direction ng ating polarity. Okay? So, ang carbon is medyo weak siya na electronegative. Mas less electronegative siya kaysa oxygen. So, which means siya yung magbibigay ng electron sa ating oxygen. So, nagkaroon siya ng delta positive. Okay? So, yung ating oxygen naman, siya yung humatak ng ating electrons and is more electronegative kaysa dun sa ating carbon. So, nagkaroon siya ng delta negative na charge. Okay? Sa methyl lithium naman, carbon is more electronegative kaysa sa lithium natin. Okay? And as you can see, yung difference nila is 1.5. So that's that this bond is considered as polar covalent bond. So yung ating carbon is more electronegative than the lithium. So meron siyang delta negative. At yung lithium natin is less electronegative, so meron siyang delta positive. As you can see, yung direction ng ating arrow is from the positive sign to the negative sign. Okay? Now, note also that calculated charge distributions in molecules can be displayed visually with what we call the electrostatic potential maps. And sa electrostatic potential maps, we use color para ma-indicate kung saan yung electron rich at kung saan yung electron poor. So, electron rich, sila yung may red. Okay, so electron rich, ibig sabihin, sila yung may negative. At saka yung electron poor, sila yung may positive na sign, okay? So, electron rich is color red, okay? And the electron poor is color blue, okay? For example, in methanol, so the oxygen carries a partial negative and is color red. So, ang carbon natin is partial positive and may color blue-green siya. Okay? And this one naman, lithium is partial positive, kaya siya ay color blue. And this carbon is partial negative, so meron siyang color red. Now, bakit ba kailangan yung ating EPM yung electrostatic potential maps? So they are useful and helpful because they show at a glance yung kung saan yung electron rich at electron poor atoms in a molecule. Now let's have this example. This is an electrostatic potential map of methylamine, a substance responsible for the odor of rotting fish. So, let's tell the direction of the polarization of the carbon-nitrogen bond. So, as we can see here, nitrogen has a red region, meaning siya yung may partially negative charge. Yung ating carbon naman, carbon-hydrogen bonds, so ibig sabihin siya yung may electron poor. So, meron siyang partial positive na charge. So, the direction of polarization is upward. Okay? So, that's how useful the electrostatic potential map is. Okay? Now, let's have your exercise number 8. Find the difference of the following bonds and indicate the type of bonds. So, before, yung kanina, meron doon yung guide kung ano yung mga difference ng 3 types of bond, no? So, yun lang. Yung electronegativity ng oxygen minus the electronegativity of hydrogen. So, kung ano yung difference nila, yun yung mag-i-indicate ko anong type of bond. Now, number 2, which element in each of the following pairs is more electronegative? So, that's easy to understand. Number 3, use the delta negative and the delta positive convention to indicate the direction of expected polarity for each of the bonds indicated. So in this one, you would tell which is electron rich and electron poor. Okay, and you would tell if you would indicate the direction of the polarity if it's to the left or to the right or to the left. Okay. So, that's it for exercise number 8. Meron pa. So, rank the following bonds from least polar to most polar. Okay? So, you would find the difference of these bonds, ayan, and then you would rank them from least polar to most polar. So, ibig sabihin, yung most polar, siya yung may pinaka mataas na electronegativity difference. Okay? So, another topic related to bond polarity is the formal charges assigned to a specific atoms within the molecules, particularly yung mga abnormal number of bonds. Yung mga abnormal number of bonds is like yung carbon natin. Carbon should have 4 bonds para ma-attain niya yung octet rule, yung para dapat para ma-attain niya yung 8 valence electrons sa kanyang valence shell. So, meron, pero ang nangyari is 3 bonds lang yung meron, 3 bonds lang yung meron siya. So, may kulang siya ng isa. So, dun pumapasok yung ating mga formal charges. So, formal charges are the hypothetical charge on an atom in a molecule or polyatomic atom. And also, the calculation of a formal charge on a molecule is a mechanism para ma-determine natin yung correct Lewis structure or yung electron dot structure natin. Okay? So, we have here the what do you call this? The formula to find out the formal charge of an atom. We have valence electrons minus the sum of the number of bonds plus the number of non-bonding electrons. So, meron akong example. Okay. So, let's look at dimethyl sulfoxide, for instance. So, sulfur, yung ating sulfur, meron lang siyang 2 bonds. So, meron na siyang 2 bonds. So, let's see. Sulfur has a atomic number of 16. So, kung i-electron configuration natin, it's 1s2, 2s2, 2p6, so that's 10, 3s2, and 3p4. So, sa valence shell niya, it has 6 valence electrons. So, sulfur is 1, 2, 3, 4, 5, and 6. So, eto lang yung kailangan mag-bond, yung ating tag-iisang electrons. Now, on our oxygen has an atomic number of 8, okay? So, oxygen is 8. It's 1s2, 2s2, and 3p4, okay? So, the valence, 3p4, 2p4. So, the valence electron is 6, 1, 2, 3, 4, 5, and 6. So, ayan. So, kailangan niya lang ng 2 bond para ma-attain yung ating octet rule. Okay? So, now, on this case, sa ating sulfur, it has 3. Okay? 3 bonds. So, paano na-determine na isa lang yung plus niya? Okay? So, meron tayong formula kanina. So, valence electrons is how many? 6 minus the number of bonds na meron siya, 1, 2, 3, plus the number of non-bonding electrons is 2. Okay? So, that's 6 minus 5. Okay? This is 5 is 1. So, this is positive 1. Kaya, nagkaroon siya ng positive sign. Now, sa oxygen naman is how many valence electrons? 6 minus how many number of bonds? 1 plus how many valence electrons? 1, 2, 3, 4, 5, 6 valence electrons. Non-bonding pala, non-bonding electrons. So, that's 6 minus 7 is equals to negative 1. So, magkakaroon siya ng negative charge. But sometimes, meron tayong, may product tayo ng negative 2, may product, may difference na negative 2 or positive 2, ganyan. So, nag-i-indicate siya ng ganyan or 2 negative. So, may mga ganon. So, may examples din naman ako later on. Okay, so we have here example on how to determine the formal charges. Okay, so oxygen, ayan, so first muna yung H3O, no? So, sa oxygen has 3 hydrogen bonded to it daw. Ayan. H3O or hydronium. Now, yung oxygen natin ay meron ng 6 valence electron, 6 electrons. 1, 2, 3, 4, 5, 6 at 7, 8 dito para ano yung ma-meet natin yung doon sa octet rule na 8 valence electrons dun sa kanyang valence shell. Now, let's determine the charge of hydrogen. Okay? So, hydrogen has a valence electron of 1 minus the number of bonds is 1 and the number of non-bonding electrons ay wala naman. Okay? So, that's 0 plus 0. Okay? So, 1 minus 1 is 0. So, walang charge ang ating hydrogen. So, let's find out naman sa ating oxygen. So, oxygen, valence electrons niya is 6, diba? Kasi meron siyang what do you call that? Meron siyang atomic number na 8. So, 1s2, 2s2, and 2p 4. So, doon sa kanyang second orbit, meron 6 na valence electrons. Now, 6 minus how many bonds? 1, 2, 3 plus how many non-bonding electrons? 2. Okay, so that's a 6 minus 5 is equals to 1. So, meaning, meron tayong positive sign dapat dyan. So, dito sa ating H3O, dapat magkakaroon ng H3O positive. So, dapat ganon. Okay. Now, let's have the nitrate. Ayan. NO3. Okay, sa nitrate. So, nitrogen natin ay meron daw nakaband na 3 oxygen. Okay. So, we have here, So, we have here nitrogen, oxygen, oxygen. So, ang nitrate has this, so meron siyang ganyang structural formula. Okay, so let's find out the formal charge. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, sa ating nitrogen, no? Okay. So, let's find out the charge for nitrogen. Okay. Equals, bakit yan? Okay, nitrogen. Number of valence electrons of nitrogen. Nitrogen has an atomic number of 7. So, that's 1s2, 2s2, and 2p3. Ayan. So, sa second orbital niya, meron siyang 5 electrons. Okay. So, 5 valent electrons. Now, minus the number of bonds. 1, 2, 3, 4. Ayan. And the number of non-bonding electron ay wala. So, lahat ay nakabond. Okay. So, plus 0. Okay, so 5 minus 4, so that's 1. So, meaning, dapat merong positive sign sa ating nitrogen. So, let's have oxygen. So, sa oxygen natin, meron tayong ilan ang valence electrons niya? Meron siyang 6, di ba? Minus the number of bonds. Itong dalawa muna ang find out natin, okay? So, ang number of bond na meron sila ay isa lang, plus yung non-bonding electrons ay 1, 2, 3, 4, 5, 6. Ayan, equals 6 minus 7. So, meron tayong negative 1. So, meron ditong negative na sign. Okay? Now, on the second one, so we have here, this oxygen here. Okay? So, 6 valence electrons minus how many bonds? That's 2 plus 1, 2, 3, 4 na non-bonding. So that's, okay, sorry. So that's 6 minus 6. So oxygen will have a zero formal charge. So walang charge ito. So this one will have two negative charges on oxygen and one positive charge doon sa ating nitrogen. So N plus, and dapat, and NO3 to negative. Okay? Dapat N plus O3 to negative. So, ibig sabihin, dalawang oxygen ang may negative charges. So, that's how you write the formal charges of an atom in a molecule. Okay? So, let's see. Okay. Now, let's move on. This is a table of the summary of common formal charges of some atoms. So, we have here the carbon, nitrogen, oxygen, sulfur, and phosphorus. Ayan. So, nandyan yung mga ang tawag na numbers ng valence electrons, ng bonds, at mga non-bonding electrons and their respective formal charges. Now, on your exercise number 9, calculate the formal charges for the non-hydrogen atoms in the following molecules. So, you will determine the carbon, the nitrogen, and the oxygen. Okay, now, you should include the formula or the solution kung paano nyo na-determine yung mga charges ng mga non-hydrogen atoms. Okay, number 2, organic phosphate groups. You will calculate the formal charges on the 4 atoms or on the 4 oxygen atoms in the methyl phosphate dianion. Okay. So, most substances can be represented unambiguously by the Kekulé line bond structures that we've been using up to this point. But, however, there's an interesting problem sometimes arises. Now, for instance, let's have the acetate ion. So when we draw a line bond structure for acetate, so we need to show a double bond on one oxygen and a single bond on the other with a negative charge on it. Pero, saan ba talaga yung placement ng dalawang oxygen? So, dapat ba ganito yung pagsulat ng acetate ion? Or should it be this way na ang double bond ay nasa baba and the single bond is nasa taas? So, although the two oxygen atoms in the acetate ion appear different in line bond structures, experiments show that they are equivalent. So, parehas lang daw sila. So, these two individual line bond structures for acetate ion ay tinatawag na resonance forms. And the resonance relationship is indicated by the double-headed arrow between them. So, pwedeng ito ang mag-exist and pwede din ito ang mag-exist. So, the only difference between resonance forms is the placement of the pi and non-bonding valence electrons. Okay? Yun lang daw yung pagkakaiba nila. So, we have here another example, the benzene. So, these are the two resonance forms of the benzene. Ayan, so ito yung kanyang double bond. But on the other, yung double bond ay lumipat dito sa kabila. So we had this forms. When first dealing with resonance forms, it's useful to have a set of guidelines that describe how to draw and interpret them. So in rule number 1, individual resonance forms are imaginary. They are not real. The real structure of a compound is a combined or resonance hybrid of the different forms. Okay? So, rule number 2, resonance forms differ only in the placement of their pi or non-bonding electrons. So, neither the position nor the hybridization of any atom changes from one resonance form to another. So, hindi pwedeng magpalit-palit ng posisyon yung mga atoms. Yung electrons, yung bonds, and yung charges lang ang pwedeng magpalit. Now, in rule number 3, three different resonance forms of a substance don't have to be equivalent. Okay? So, as an example, let's have the acetone. So, in acetone, which contains a carbon oxygen double bond, it can be converted into its anion. Okay? Anion when reacted with a strong base. Now, the resultant anion has two resonant forms. So, one form contains a carbon-oxygen double bond and has a negative charge on the carbon. Ayan. On the other form of anion naman, a carbon-to-carbon double bond and has a negative charge on oxygen. Now, even though the two resonance forms aren't equivalent, both contribute to the overall resonance hybrid. Ayan. So, nakikita niya yung bonds lang din naman and the charges ang nagkaroon ng parang paglilipat. Okay. So, in rule number 4, resonance forms obey normal rules of valency. So, the octet rule still applies to second row main group atom. So, meron pa rin dapat na 8 valence electrons or 8 electrons. Okay? Like this one. 1, 2, sa oxygen, 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So, meron siyang 8 valence electrons pa rin. On this one naman, 1, 2, 3, 4, 5, 6, 7, 8. Oh, madami. And 9 and 10 electrons on this carbon. So, it's not a valid resonance form. Rule number 5, the resonance hybrid is more stable than any individual resonance form. So, resonance leads to stability. So, let's have this molecule, and for us to have formal charges on this molecule, we can react it with a base para maka-remove tayo ng isang hydrogen para magkaroon tayo ng anion form. Okay? So, this 2,4-pentane dione, so when we react it with the base, so nagkakaroon tayo ng anion form ng compound na ito. Okay? So, how do we draw its resonance form? Okay, let's have an example. So, this one is already a resonance form. So, we will determine the other forms of this anion. So, H3C, ayan, and then C, let us first transfer this negative sign and the lone pair electrons on oxygen, and we will transfer this double bond here into carbon to carbon if it's applicable. Okay, double bond O, C, H, C, single bond O, and then the two lone pair and negative there, and double bond here, and CH3. Do you think it's correct? So let's count the electrons of this carbon. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. How about this carbon? Okay, so let me elaborate the structure of this carbon. See, okay, so C, so it has 3 hydrogen atoms. So let's count its electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it has 10 electrons. So ibig sabihin, it cannot, this form is not valid. So let's try another. Let me fix that first. Okay. Oh, so this one is C. Um, okay, so let's try if we would transfer the electrons and the lone pair electrons and the negative charge on oxygen here, but now we will transfer the double bond here. Okay, oxygen, and so dyan ko na lang sinulat ha para makita the negative sign and then CH3. Now let's count all the electrons they have. So oxygen, 1, 2, 3, 4, 3, 4, 1, 2, 3, 4, 5, 6, and a negative charge. Okay. Now on carbon, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So dito naman, sa CH, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So this is a valid resonance form of acetate anion. So let's have another one here. So H3C, and C. So I will do transfer this to the other oxygen, and this double bond I will transfer here. Okay, so let's see if it's applicable. H, C double bond O, CH3. So this one ay O, and then yung dalawang electron, and then so I'm sure that this is right. Okay, one for the C, for this carbon, 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 electrons. On this one, 1, 2, 3, 4, 5, 6, 7, 8. So meron siyang 8 electrons. On this one naman, 1, 2, 3, 4, 5, 6, 7, 8. So, and then a negative sign. Yes. Okay, so these are the two resonance forms of pentane anion. Pentane dianion. Okay. So there. Another example is this one. Draw the 3 resonance structures for the carbonate ion. So, ang carbonate ion has a what do you call this? two oxygen atoms that has negative sign. Okay, so meaning the other atom has the other oxygen atom has a double bond on C. Okay, so this one is negative and this one is negative, and there. Oh, let me transfer that na lang sa ano natin, sa paint. Okay, so carbon and ion there. O negative, O negative, and it's 1, 2, 3, 4, 1, 2, 3, 4, and let's see. So it's this is uh, the first resonance form, of carbonate ion. So the other one, I will just transfer the double bond here and there. Negative 1, negative. What did I? Okay, so the negative here and the negative oxygen here. Then I will just put the valence electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, and this negative charge. 1, 2, 3, 4, 5, 6, and the negative charge. Okay, so this is a valid resonance form. So another one, I'll just transfer again the double bond here. Okay, so this negative, why did I do that? Then here, oh, negative. So this is also a valid resonance form of acetate and ion. So now let's learn how to draw the resonance forms for a radical. Okay, so a radical is a substance that contains a single or unpaired electron on one of its orbital sa valence shell. So this is an example of a radical, the pentane diennyl radical. So in drawing the resonance form for a radical, we should find first the three atom groupings that contain a multiple bond next to an atom with a p orbital. Okay, so this one is a three atom grouping that has a p orbital because we have a double bond here, and also this one. Okay, so so let's have its radical form. Let me. Okay, so this one is already a resonance form for that radical. Now, sabi natin, ihahanapin natin yung three atom grouping, and this is one of the three atom groupings. And what will I do is I will transfer the carbon over here, the radical over this carbon, and this double bond I will transfer here. And let's see if it's a valid resonance form. Okay, see, condense this into CH2, okay? Then double bond C, H, then C, and then it's radical, then H, then C, then double bond over here, and H here, and H2. So let's see if it's valid. Let's count. On this one, this carbon here, 1, 2, 3, 4, 5, 6, and a radical here. Yes. On this one naman, 1, 2, on this carbon, 1, 2, 3, 4, 5, 6, 7, 8. So meaning this is a valid radical form. Now let's have this group naman. So what will I do is I will transfer the radical on this carbon. Okay. Mm-hmm. C H H the radical, and then I will transfer the double bond here. Okay. Now C double bond, the H here, C H. Then as I transfer the double bond here, I will also transfer the double bond on this carbon. Okay, there you go. And H. So as you can see, this is valid because the electrons are still 8 on the valence shell, except for this one kasi on this group kasi meron naman siyang radical here. So this is a valid resonance form of the pentane dienyl radical. Okay. So what if I will do I will do this, then C, then I will put the radical here, then H, then C, then double bond C, H, okay? 2 and H, okay? So, as you can see, this is not a valid radical form because on this carbon, meron siyang 1, 2, 3, 4, 5, 6, 7, 8, and a radical. So, sobra-sobra na yung electrons na meron siya. So, hindi siya valid na radical form. Okay? Okay. Now, on your exercise 10, draw the indicated number of resonance forms for each of the following species or each of the following compound. So, the metal phosphate ion, ayan. So, ibig sabihin, tatlo daw ang kanyang resonance form. Ayan. Sa nitrate anion, tatlo daw ang resonance forms niya. The allyl cation, may dalawang resonance form, and the benzoate anion, which has a resonance form of 4. You can search for the actual form of this compound. Then you would draw the resonance forms na lang. So may libre na kayong isa na resonance form for each of these compounds. Okay. So perhaps the most important of all concepts related to electronegativity and polarity is that of acidity and basicity. So there are two definitions of acidity that are frequently used, and these are the Bronsted-Lowry definition and the Lewis definition. So in Bronsted-Lowry definition, when a hydrogen chloride, for instance, when a hydrogen chloride dissolves in water, so a polar hydrogen chloride molecule acts as an acid and donates a hydrogen, while a water molecule acts as a base and accepts the hydrogen, yielding chloride ion and hydronium ion. So this and other acid reactions are reversible, kaya meron tayong forward and backward arrows. So The chloride ion, the product that results when the acid hydrochloride um, loses a proton, is called the conjugate base. Ito namang hydronium ion, this is the product that results when the base gains a proton. Okay, so this is now called a conjugate acid. Okay, so acid plus base is equals to conjugate base plus conjugate acid. So in general sense, ayan, the acid will donate a proton or a hydrogen, most commonly hydrogen and dinodonate, when we react it with our base. So we will have a conjugate base from the acid. So it will have mostly the conjugate base has a negative charge, and we will have a conjugate acid, a product of this base. Okay, so it will gain a proton. So magkakaroon siya ng positive charge. Ayan. We have here another set of examples. The reactions of acetic acid and hydrochloride, then water and ammonia. So first, let's have the reaction of acetic acid and hydrochloride. So acetic acid serves as the acid as it gives off the hydrogen to our base, which is the hydrochloride. So this reaction would yield the conjugate base na acetate ion gaining negative charge since nawala yung kanyang hydrogen. Now, and a conjugate acid na ayan, a product of the base. So, ang conjugate na acid natin is water. On this one naman, ang ating water and ammonia. So, the water serves as an acid and it gives off its hydrogen atom to our ammonia. So, yielding a conjugate base na hydroxide, and a conjugate acid na ammonium cation. Okay? So, ang ating hydrochloride has a negative charge and ang ating ammonium cation has a positive charge. So, that's the reaction ng mga acids and bases. So, let's have another working example, the nitric acid and the reaction of nitric acid and the ammonia. This would yield ammonium nitrate. So let's identify the acid, the base, the conjugate acid product, and the conjugate base product. So let's first write the reaction. Ayan. Plus the ammonia, which is NH3. Okay. Ayan siya. So, this nitric acid would give off its hydrogen to our ammonia. So, magkakaroon tayo ng NO3 plus NH3, which is NH4. And when we add this two compounds, we would have ammonium nitrate. So that's NH4 NO3. So in NH4 NO3, ayan, our conjugate base of our acid is NO3. Okay, so the conjugate acid of our base is NH4. So, yun yung kung paano i-identify ang mga reactants and the products. Okay, so acid is to conjugate base, and base is the conjugate acid. So, exercise 11, write the products of the following acid-base reactions. Okay. So, ano nyo, ang tawag nito, isulat nyo yung mga products nito, and then you would identify which is the base, which is the acid, and which are the conjugate acid and base. Yes. There. Yes. Ito na. Now, acids differ in their ability to donate hydrogen ion. So, stronger acids, such as hydrochloride, react almost completely with water. So, whereas weaker acids, such as acetic acid, react only slightly. Okay? So, the exact strength of a given acid in water solution is described using the acidity constant para sa acid dissociation equilibrium. So this is an example of the acidity constant. So ito yung example formula niya. However, acid strengths are normally expressed using the pKa values rather than yung sa Ka values niya. So, yung pKa values, ito yung negative common logarithm of the Ka. Now, usually, pKa nga, diba, yung nasa pKa, yung acid strength ng ating mga acids. Now, how do we calculate Ka from a given pKa? So we have this equation. So Ka is the negative logarithm of negative pKa. So for example, we have number 1, acetic acid has a pKa of 4.76. So what is its Ka? So I would, in a calculator, so iaano nyo lang, sa calculator, hanapin nyo yung anti-log, ayan, o kaya yung invert, then log, yun yung invert, then press invert, then log, then negative 4.76. So, you would have a Ka of 1.74 times 10 to the negative 5. Ayan. Ganito lang. Wait lang. Invert, then 10x ata yun. Ayan, magiganyan siya. Then yun, negative Ka. pKa, pKa. So, ganun lang siya makikita sa calculator or sa phone. So, what is the Ka of HCN if its pKa is 9.31? So, if I would follow this solution or equation, I would have a Ka of 4.9 times 10 to the negative 10. So, I will just include, or I will just comment a screenshot on what the keys you would press doon sa ating calculator. So, let us remember that a stronger acid has a smaller pKa and a weaker acid has a larger pKa. So, for example, ang ating phenylalanine, an amino acid, has a pKa of 1.83. And ang tryptophan natin, it has a pKa of 2.83. So, in this statement, the stronger acid would be the phenylalanine because it has a smaller pKa. And a weaker acid is the tryptophan. Okay. So here is a table of our acids and their respective pKa. So notice in our table that there is an inverse relationship between the acid strength and the base strength. Okay, yung conjugate base niya. So, a stronger acid, for example, the HCl, has a weak conjugate base. And a weak acid like ethanol has a stronger conjugate base. So, a strong acid is, masasabi natin na ang acid is strong if madali siyang magbigay ng hydrogen. So, ibig sabihin, yung conjugate base niya, nag-hold siya ng weaker hydrogen bond. Okay? So, a weak acid, kunyari ito nga, yung water, kunyari, ang weak acid natin is water. So, siya yung naglo-lose ng hydrogen na medyo mahirap. Mahirap siya mag-lose ng hydrogen. Meaning, yung conjugate base niya, yung hydroxide ion, it holds the proton tightly and thus is a stronger conjugate base. Okay. So let's have an example. So cyanide ion is a much stronger base than acetate ion. So which is the stronger acid, hydrocyanic acid or acetic acid? So cyanide ion is a conjugate base of hydrocyanic acid, and acetate ion is the conjugate base of acetic acid. Now cyanide ion is a stronger base, making the hydrocyanic acid a weak acid. Okay, so acetic acid has a stronger strength, or a stronger acid strength. So it has a weaker base. So in this problem, the stronger acid would be acetic acid, since its base is weaker than the conjugate base of the hydrocyanic cyanic acid. Okay. Okay, so in exercise number 12, you would determine which is a stronger acid and which is the stronger base in this set of problem. Okay, and please include a short explanation on how you come up with that answer. Excuse me. Okay, next is find the Ka of the following compounds. And show the solution. Okay. So next are the organic acids and organic bases. Organic acids are characterized by the presence of a positively polarized hydrogen atom. Okay, so there are two forms or kinds of acids. We have acids that contain a hydrogen atom bonded to an oxygen atom. So an example of this is the methanol and the acetic acid. So there's a hydrogen atom bonded to our oxygen. And there are also acids that contain a hydrogen atom bonded to a carbon atom next to a carbon double bond oxygen, a carbon oxygen double bond. Okay. So for instance, we have this acetone. Ayan. So it has a hydrogen atoms bonded to carbons, which these carbons are bonded to a carbon that is double bonded to oxygen. So those are the kinds of organic acids. So we also have the carboxylic acids, which contain the COOH grouping. So carboxylic acids occur abundantly in all living organisms, and they are all involved in almost all metabolic pathways. So, examples of carboxylic acids are acetic acid, pyruvic acid, and citric acid. So, you can see meron siyang um, hydroxyl groups. Ayan. So, organic bases are characterized by the presence of an atom with a lone pair of electrons that can bond to hydrogen. Ayan. Though, so, the common basis has nitrogen. For example, this one, the methyl amine. So this methyl amine and nitrogen-containing compounds are the most common organic bases, and they are involved in almost all metabolic pathways, just like the carboxylic acids. Then meron din tayong mga oxygen-containing compounds like this one. They can also act as bases when reacting with a sufficiently strong acid. And also note that some oxygen-containing compounds can act both as acids and bases depending on their circumstances, gaya nung kanina ng water. So methanol and methanol and acetone, for instance, act as acids when they donate a proton, particularly hydrogen, but can also act as bases when their oxygen atom accepts a proton. So pwede pa siyang maglagay pa ng H. So magkakaroon siya ng positive sign. So that ends our Unit 2